Hello. Hello, hello. Welcome, everybody. I'm so glad that you're here. I'm going to get things started while we continue to do a little technical difficulty troubleshooting. Um, I am so excited that you all found this place because we've had trouble with our deliveries not making it to us. This is our first month in this new building, and I should also say I'm Jill McAverna. I'm the I'm the organizer for tonight's meetup with the help of many other people, and we have a lot of things to be excited about with our meetup tonight. Of course, first and foremost, our new space. I hope you would help me give everybody a round of applause who helped make it ready for tonight. Another thing to be particularly excited about, at least I think, our datapluscreativity.com website. We have our first guest blog published, and the author is here in the audience tonight. Victor, do you mind raising your hand? Victor was our speaker last month, and he gave this great talk about how technology could be used to improve crisis response and humanitarian aid efforts, and he turned it into a wonderful blog post, and it's on the website now, and I encourage you all to go check it out. The third thing that we're really excited about, this month is the 1-year anniversary of the Data Plus Creativity newsletter. We started it in March of last year, and almost made it every month. There was one month where we missed it, but and if you've never seen the Data Plus Creativity newsletter, it's probably because you have to sign up at exaptive.com/newsletter, and we're trying to figure out the relationship between Exaptive and Data Plus Creativity. You know, Dave King, our CEO, the CEO of Exaptive, I'm the community development director at Exaptive, and Dave started this group almost 3 years ago. It's pretty crazy. I think on the meetup site it tells us that this is meetup number 36 for Data Plus Creativity, and Dave really established a tradition of having excellent speakers and drawing a really interested crowd, and we just have these great discussions. And on the Exaptive side of things, we just need Dave to focus on some other things, and we have lots of people willing to jump in and carry the Data Plus Creativity torch because it is such a fun group. You know, part of that is we definitely encourage you to tell your friends about it. Like, this is one of my favorite things that I do in Oklahoma City is come to these meetups, because it's like you guys are all my thinking friends, like the ones that actually, you know, are interested in innovation and innovative ideas and putting them into action. And so we've been having these great discussions for years, and we're moving in a direction where we want to make it more of an opportunity to participate in innovation and not just talk about it. So we'll be doing more with that next month, but I'm super grateful that Dave has said, you know, Exaptive is going to keep sponsoring these events, and you know, we'll get to use Exaptive software for some things, and so that's the relationship. We want Data Plus Creativity to grow and be independent of Exaptive, but there's still always going to be a pretty tight relationship there. Let's see, I wrote my notes on my arm.
I think we have.
Awesome.
Yeah. Do you want
I think it'll be all right.
Did you?
Not yet. I was debating whether to wait until like after the, like send them on home, send them home wanting to come back next month. So, okay. Well,
I was busy.
Not yet. That's what we'll do right now. One of the other wonderful traditions that I really like that Dave started is we always invite anybody who is their first time at the Data Plus Creativity meetup to stand up and introduce themselves. This is, obviously a microphone because you can hear me. The foam part is where you speak into, but it's also encased in foam so that you can throw it across the room and other people can catch it and talk into it. That's why it's called a catch box. Is there anybody new here tonight that would like to share?
Hey, my name's Hassam Nadeem. Okay. My name's Hassam Nadeem. I work down at the FAA. I'm a full-stack software developer and a Linux system administrator. Go back.
Hi, my name's Brandon Yench. I do SQL stuff at any job that hires me for it. So.
My name is Brian Carroll. I'm a graduate student at UCO in applied mathematics and computer science, and my specialization is AT related. High performance computing, so like MPI, OpenMP, that sort of stuff. So.
I really wish
Hi.
the SQL guy. Contract equals true.
Hi, my name is Ho Chang. I go by Michael. I'm a professor at UCU. I'm teaching the analytic courses, including data mining and programming for data analytics. So I came to see how this course.
How polite. My name is Ben Bramer. I'm the director of product at WeGoLook.
Hi, my name is Umesh. I'm in the data science program at OU.
Hi, my name is Sai. I'm like a data guy at Transaction Data Systems.
Hi, my name is Dheeraj. I'm doing my master's in data science at OU. Hi, I'm Praveen. I'm a master's student as well in OU in data science.
True. This is so cool. I am so excited to see so many new people here. I'm just so glad that you're here and that you found the building. And I'm gonna let one of our exaptive data scientists introduce our speaker tonight because he has a special connection with him. Austin Schwinn is gonna introduce Dr. Dearman tonight.
Oh, thank you. Well, it's my pleasure to introduce Jacob Dearman. Jacob is the director of the Center for Data Analytics at Oklahoma City University. He's also associate professor of economics, correct? Full professor. You need to update your LinkedIn. Yeah. I was just trolling that earlier. You need to update it. Before that, he got a PhD in economics at OU. And I know you have a bachelor's in chemical engineering at OSU. On a personal note, Jacob has had a huge role in my life. From before I even had any classes with him, he has a bit of a lore around OCU of being a very difficult professor who expects a lot of his students. Luckily for me, that resulted in me getting to learn R and starting down this whole data science path, eventually mentoring me through my master's in machine learning, and then eventually introducing me to Dave and ultimately landing me in my career here at Exaptive. So it's really more than a pleasure to introduce Jacob. It's been great going from a student professor relationship to colleagues and dare I even say friends. Probably a couple years away from being equals, but maybe if I keep learning. So in the meantime, I'll let him present this stuff. So without any further ado, the Jacob Dearman.
Thanks, Austin. Thank you for that kind introduction. I'm an economist, as Austin mentioned, and normally they keep us in the office, right? They try not to let us out among real people because we're the dismal scientists and we bring sort of the mood of the room down a little bit. So, but hopefully for what I lack for in charisma, I'll make up for it in a little bit of content here in this presentation today. So, an algorithm to improve outcomes for students in universities. Most of this has already been mentioned by Austin right here, my background. My current academic research interests are a little bit different than what I'm presenting on here. I'd like to apply machine learning methods and develop machine learning methods for spatial processes, particularly Gaussian process regression is my main focus, and marrying that with Bayesian model averaging. Should have another paper out soon that scales it to big data. But anyway, so this is my brief background. And the outline for today's presentation, maybe you saw some of this on LinkedIn, but how macro level conditions drive discounting. So we want to set the backdrop for why is discounting important in higher education, and how discounting affects both two different outcomes, both academic and financial outcomes for the university. What is that student level objective? So if we look at an individual student, what does that trade-off look like? And then as we move from the student, then we move to the university level perspective and look at sort of the opportunity cost. So just the sort of the background, the backdrop, universities are, you read all the time in the Chronicle of Higher Education how tuition is going up, it's astronomically high, and yet universities are doing bad and that they're going to go out of business soon because of all this financial pressure, right? But one of the other things that you might read is discounts have increased, students have become better negotiators, and there's more competitors in the space. So this is sort of the backdrop. Let's sort of dig into the details a little bit about what's driving some of these headlines. Now, if we look here, right, we have the baby boom. We're all familiar with the baby boom, but the baby boomers had babies. And those babies that they peaked in about this, you can't really see this very well, but it's about 1991, 1992-ish timeframe. And so you're thinking right here, this is a future population of students, right? It is growing pre-91, and then post-91, 92, it starts to decrease. And we actually see this in the data, that we see this enrollment in millions. It peaks about 2010, and then it starts to decline. So what is this? So from Econ 101, this would be a demand side factor, right? This would be something that would drive your demand down, that you have fewer customers out there. Now, by the same token, though, if we're looking at the number of universities over time, the number of universities are growing at the same during this time frame. So here's that 2010 line, right? The same, if we go back, 2010 is when we once again saw a decrease in enrollment. At the same time, we see that the number of universities, both private and public, are increasing. Okay. So we're seeing a supply side factor, we're seeing a supply increase, we're seeing a demand decrease. And so if we look at this, more universities are going to shift the supply this way. And then we're seeing fewer students, demand decrease. What's that going to do? Well, what that does typically from your principles of micro days, right, is to put downward pressure on your prices. Now, how does that work? We see increasing tuition. We see the discussion in the papers of high tuition. So here, right here, and I'm sorry, I have okay, down here, right? If you're wondering where I got that data, it's underneath the screen apparently. But if you want the slides, you can look at that, and all these things are referenced. So, but over here you see increases in tuition over time, but this is net tuition. So this is actually what the students pay. So at 2010, while we saw pre-2010 we saw this increase in net tuition, what the students actually pay. Then about 2010 we see a decrease. And we also see that in another graphic over here that got shifted. But we see that this is the discount, percentage of discount right here. So really effectively, what does that mean? That means that students are paying, could be paying a little bit less. Okay, so here's the bottom line. We have more competitors, we have fewer students. And those competitors that we have, a lot of them have a broader reach because of online programs. And so what we're operating in is a more competitive environment. And that more competitive environment can lead to depressed prices, or in our case, those prices are reflected as discounts, right? Now, there are other responses to this. So we can hire really expensive consultants to recruit, and universities do this all the time. There's a whole host of these that they pay a lot of money to recruit for them. The other thing is you'll see advertisements everywhere, right? And so some universities want to differentiate their product from other universities, and they do that through advertising. I remember driving on a highway. I have four kids at home, and there is a picture put up by a university of lady that's in front of a laptop holding a baby, studying and smiling. I'm like, this never happens, right? So I have 4 kids. I know that this never happens. But what are they trying to do? They're trying to say, you can do this on your own time and in your own way. We're a different university. Please come to us, right? So advertising is a way of doing that, differentiating your product. Another way is economies of scale. So economies of scale, you might achieve that through mergers and acquisitions. And in fact, if we look over here, in the 2000s, there were only 12 mergers and acquisitions in the U.S. higher education space. Through the first 7 years, of 2010 through 2017, there have been 24. So they've been double in the first 7 years. So these are ways, these are responses to this more competitive environment. What we want to focus on today, though, is really none of those, but sort of the discounting, right? And how does this play out? So I actually had this idea back in about 2008, 2009. The VP of Enrollment at the time, which is not OCU's current VP of Enrollment, was asking me some questions, and I started to realize what was going on. And so this was sort of playing out at OCU in some respects about a decade ago. So the CFO, motivated by found that the bottom line didn't hit the numbers that he was expecting or wanting. What does he decide to do? He decides to increase tuition, right? And the enrollment VP is operating under a completely different incentive than the CFO. The CFO is operating under the bottom line incentive. The enrollment VP at the time was operating under a numbers. How many students can you get into OCU, right? And so the enrollment VP sees this increase in tuition and incentivized by just getting the number of students. What does he do? He increases discounts. Okay, so he increases discount to certain groups. And what does this do? This exacerbates the issue. So we don't hit the numbers that the CFO was looking for, because all of a sudden all these students no longer are paying as much as he expected. Now this leads to an economic concept called third-degree price discrimination, and it's exactly what universities all over the world do, right? Third-degree price discrimination. We're going to charge different prices to different groups. And we're going to do this in a socially acceptable way. And the way that we do this is we're going to charge a really, really high price and say that you're so awesome that we'll give you a $10,000 scholarship because your ACT and high school GPA is such that you're only going to have to pay $15,000, right, instead of the $25,000. And you think, man, that's fantastic. Thank you for that. But if we had reflipped it, right, and we said that the best students only have to pay $5,000, but you're not a best student and you're going to have to pay another $10,000 to pay $15,000. That's going to make you really upset, right? You're going to say, wait, why do those people pay $5,000 and I have to pay $15,000? So this happens all the time. This would be a scholarship matrix that a typical university would publish, where we have, like, say, this is for merit-based. They have ones for need-based as well. But you'd have a GPA right here and the ACT, and then you find which bucket you fall into, and this is going to be your scholarship. So this is third-degree price discrimination. We're charging different prices effectively to different groups of students. And if you wanted to look, there's an article on this, econ article, EPL 2017. Once again, it's somewhere down there if you can read that. Our topic today, though, is a little bit different. It's a first-degree price discrimination. Yes? Yep. Why is it called third degree? Why is that third degree? That's a great question. I probably need to get back to you on that. We'll talk about first degree price discrimination, where we're going to charge. So third degree, we're doing groups. First degree, we're going to do individuals, right? We're going to charge a different price to each individual. There is a second degree from my IO days, but that was 10 years. That was like 10 years ago. Let's see, how many years ago? That was over 10 years ago now. Oh, that's like 12 years ago. Okay. But what we're talking about today with first degree price discrimination, where we're charging a different price to each student, really, by applying discount, this whole concept can also be applied to third degree as well. Okay. Now, what does this sort of first degree price discrimination concept look like? Imagine yourself as a counselor, right? As an enrollment advisor, and you're sitting in your office, and a freshman student walks in, and that freshman student comes into your office and says, hey, I'm not going to be able to make it back next year. I need another $4,000 to make this happen. Okay, this is a situation that people face every day. And so what do? Well, you look up their information, you find that they're a 27 ACT, they've got a 3.0 GPA. And so you need to figure out if the student is at risk for leaving. How do you figure that out? What information do you look at? And how do you define sort of at risk? And if you decide that maybe this student actually does need a scholarship, how much should you provide him or her, right? How much should you give them? And if you only have a fixed pool of scholarship dollars to dole out, to hand out to students, let's suppose you only have $20,000, how does this extension of a scholarship to this individual affect the scholarships made to other students? So if you gave this student the full $20,000, for example, then you would have no other funds to give to other students that might walk through your door. And so how effective, and then we need to be able to measure how effective is your scholarship dollar? What kind of rate of return are we seeing here? Okay. Now, so back in 2000, like I said, back in 2009, when I was thinking about this problem, here's what I realized. We have one control knob that affects two outcomes, two important outcomes in the exact opposite directions, right? So this would be like turning the volume on your car radio, right? Because you want to listen to music, but it also slows down your car. This is terrible, right? You want to listen to it, you listen to it too loud, your car stops. So here we provide, in this case, we provide tuning. If we give somebody a full ride, the retention probability is 100%, but they're not generating any revenue. So the car stops, the university stops. There is this trade-off here. So we have one control knob, two outcomes, the retention and the net revenue, and they move in opposite directions. So there's this trade-off that exists. And so now we're going to delve into each one of these outcomes. So the net revenue is just really easy. It's in accounting. It's just tuition fees, housing. You can put some other stuff in there as well, and discount. Notice that this is going to vary by student. There's some complexity here when you actually take it to the data. But tuition fees, housing minus discount. It's a straightforward sort of formula if we think about it from a broad standpoint. Now, retention, this is the great unknown, right? This is the thing that we have to estimate, and we'll go into a little more detail when getting the data science section. But we will need to estimate a retention probability for each student. So the question is, we have a database. We see all these retention decisions, right, of students. They're either retained or they're not retained. And then we have all these characteristics that are tagged to them. And so the question is, how do we estimate this, right? A student with a 1.0 GPA is less likely to be retained than a student with a 3.0 GPA, all other factors. Here, I will just read this off for you. It's preferences. And so preferences, you might say, where do we get preferences from? Preferences oftentimes come from surveys and stuff. So all of you have been probably students in the university settings. They send out surveys, at least at OCU, it seems like every other day, or they used to. And so you have all these factors. Then the question is, what weights do these factors receive? Where you put them in the probability model, and then you get a retention probability for each student. So the student level objective. So what we're going to do is we're going to construct our objective. And this is really important, I think, in business in general. And I'll talk a little bit more later on. This is probably like sort of the key insight. The data science stuff is fairly standard, but the key insight is that we need to construct objectives when you do data science. And so for this particular case, I constructed an expected net revenue metric. That expected net revenue metric consists of retention, probability, and net revenue. Now let's think about what that sort of means, right? So what is if we take a student, if they do return next year, then they generate zero revenue. Should they return, they'll generate a revenue stream for the university. So it's going to be the probability that they return times the net revenue should they enroll, right, or should they return. So that would be our expected net revenue metric. Okay, so if we look at it, what does this look like? So here's just an imaginary student, not violating any sort of FERPA here, just sort of made up these numbers. But if we look, the retention probability, these are additional scholarship dollars. As we increase scholarship dollars, let's say a retention probability goes up, the net revenue is going to go down, because what are we doing? We're increasing discount right here. We're holding everything else constant, so it's going down. And then the expected net revenue forms this sort of quadratic, has this quadratic form. that peaks at 4,000 there, 4,000 scholarship dollars. And so what are we considering? So if we're looking at the individual student level, over this region up to about $4,000, what we're seeing is that basically gains in retention probability exceed the net revenue losses brought on by additional scholarship dollars. Right? That as I give more scholarship to this individual student, we're seeing greater gains in retention probability than we are seeing net revenue losses. Now, once we get past that peak of 4,000, then we see that the net revenue losses outweigh the retention probability gains. And so for this individual student, maybe a $4,000 scholarship might be optimal. Okay, but that's for an individual student. Like I said, it's not. University doesn't look at a student. The university looks at a set of students, a collection of students, and we deal with finite resources, and we deal with a fixed pool of scholarship dollars that we can dole out. So that means since we have a scarce resource, that's a constraint, and we have to make choices under that constraint. Right? Okay, so let's start here with a picture that most university administrators are familiar with. This would be called like an enrollment funnel or retention funnel. Oh, sorry. And what we might have are huge numbers that apply, fewer that are admitted, and we can think of like all the existing students falling in this retention funnel. And so fewer that are freshmen, fewer that are sophomore, a little fewer that are juniors, and then fewer that are seniors, right? So that's what that looks like. So if we have 10,000 students apply, we have only, let's say 7,000 here, then 6,000, 5,000, right? And it's because of attrition. Now, what we would like to do, and what would be in the best interest of the university and for students, is that when we're looking to allocate scholarship dollars, we would like to identify those people that fall on the edge of the retention funnel, right? That fall on the edge. If you're right here and you're going to matriculate all the way through, you might deserve a scholarship, but it probably isn't a retention scholarship. What we want to do is we want to identify the people that are on the fringe here. So Bob, I hope there's nobody named Bob here. I'm not picking on you, Bob. But Bob is going to leave the university. He's at high risk for leaving the university here. And what we would like to do is provide Bob a scholarship to improve his financial situation, to push him into the retention funnel so that he matriculates through. Now, you can sort of see a broad thought here, one that I don't go into much, or don't go into in this presentation, but I'm talking about expected net revenue, and really another metric and a metric that I employ is an expected net revenue stream. So by pushing Bob from here to here, we can see that his expected net revenue stream has increased greatly, right? So he's going to generate, here he only generates revenue as a freshman, here he'll generate revenue as a sophomore, junior, and senior. He will be retained, so it'll improve our financial outcome. He will be retained and graduate, so he'll improve his position as well by graduating with a degree from our university. Okay, so the question is, how can we identify these people and allocate scholarships? And so the big idea here is, once again, we have a fixed pool of scholarship dollars, that there's an opportunity cost associated with these dollars. Hopefully you guys are incurring opportunity costs right now, right? Sitting in here, that you could be out in Midtown, right? Over at McNally's instead of sitting here. So you're incurring opportunity costs. And just like the dollars that we're allocating, those have an opportunity cost. They can be put to other students or put to other ends. And so how do we do this? And so here's the basic, so we can identify at-risk students, and the way that this typically worked was that there was some criteria that we were looking for, a class of students that would be considered. And then through that class of students, we would identify those that were at risk. So if you had an incoming class of 4,000, maybe by imposing that first sort of class of students you're looking at, it reduces it down to 1,000 or less. And those are students that have some sort of financial need. And what we can do, once we identify, we can estimate a retention probability and expected net revenue for each student. And so if we have, let's say, 600 students that fall in this, what we would want to do is we would want to take a $100 scholarship increment, look across all students, all 600 students, and see where sort of the gain and retention probability exceeds the net revenue loss by the greatest amount. That is where we're going to get a biggest bang for our buck. So so we're going to do that, and then we will increment $100 by $100 by $100 over and over again until it's all allocated out. And what we can do is, once we're done, we can rank our allocations. We can say, where do we see the greatest gain? And where do we see in retention? Where do we see the greatest gain in expected net revenue? And then we can even choose a hurdle rate if we wanted to. We can say, well, we want to invest this many scholarship dollars, and we will expect that we will see a retention. We'll keep 5 additional students for this allocation. Notice that if you make a scholarship offer and that student is not retained, then that money goes back into the pool. Okay, so that was building the objective. That's probably the most important part of this whole thing. Now, here's the data science part. So one of the things that I want to point out, so the SQL guys, you guys are awesome with data. So we have the whole data. How is it being measured? What is being measured? How frequently is it being measured? How accurate is that data? And then once we go from data, and I've left off visualization, so for Tableau people out there, I'm really sorry. I was running out of room. I wanted to put visualization on there. And then estimated relationships. So once we get data, we can estimate relationships. And we typically have two primary purposes for that. One's prediction, and one's for explanation, right? So prediction and explanation. In our case, we're primarily looking at prediction. We're not as concerned with explanation. Explanation might be, does a policy, what is the impact of a particular policy? You could look at that. But we're looking at prediction. And so these are the questions that typically would go through. And then we want to embed this estimated relationship for prediction into an optimization routine. Okay, so this beautiful chart, this is visualization, and this was kindly provided to me by Sean Spencer, data science, business intelligence director at OCU. Thank you. So these are all our data sources at OCU. I mean, and we're not a huge university, and so you can imagine as you go to larger and larger universities that these just grow. And so there's a lot of there's data here. And then I also put down here plus surveys, right? So this doesn't even include all the surveys. And I thought it was fitting that Neil Lawrence, University of Sheffield, he's also he's an awesome data scientist, and he also works for Amazon. Here's what he puts: just as extracting drinkable water from the real ocean requires the expensive process of desalination, extracting usable data from the data ocean requires a significant amount of processing. I did not realize this when I first got started, how onerous some of the stuff was going to be, and how many layers I would have to process to get it to the form that I needed it to be. Just to highlight a few of the issues that I ran into, the information set changes over time. So all during the semester, you're getting more and more pieces of information. And so, for example, if you're looking for college grades, those aren't typically recorded. First semester college grades aren't typically recorded until right before the spring semester. Or if you're looking at expected family contribution and you want to use that in your analysis for next year, well, then back when I was doing this, you would have to wait till about I think it was March or April. Okay, so this information set is changing over time. And some of the really important points may not actually be captured by the data itself, right? And so you could have athletes whose coach has told them that they are not going to receive a scholarship next year, that they're going to be cut from the team, and they've made a choice to transfer. And that may or may not be reflected in the data that you have, right? Okay, so this is one of the things. And other data, such as membership roles. So I got an Excel file full of 700 tabs of group memberships. Each tab was a different group, right? And so then I had to take that, load it in, write a script that would load it in, and then from that, construct a social network map. So we can think about how that might work. We can think of, we'll pick on Bob again. Bob being in SGA and Bob being in Kappa Sig. Well, Bob is connected to everybody in SGA and Kappa Sig, and then if Mary's in Kappa Sig and Pi Phi, then he's secondarily connected to Pi Phi, right? So what you might see here is you could construct the social network. This is an old one. This is a really old one. So I wasn't violating any sort of FERPA issues. And what you can do is for each point, construct a centrality measure, right? So you basically that centrality measure is going to determine sort of the connectedness or the distance from that individual student to every other student on that plot. And you put in a retention probability, and now you're matching up with sort of the social integration component that Tinto talks about. All right, so given all these data sources, we have a lot of data. And this is just a sort of brief overview, and some of you might have seen some of these slides before, but we'll go through it pretty fast. A model, so we have a collection of data. A model is a set of explanatory variables. So we're thinking of the characteristics of the individual student as they relate to the retention decision. And so a model would be different collections. So if we just have 4 different X variables, 4 different characteristics of the student, we can see that there are 16 possible model combinations. So the distance from the university to their house, financial need, high school GPAs, ACT. And so as you grow K grows exponentially to the K. And so you see something that looks like this. For 32 variables, there are 4.3 billion possible models. So how can we sift through these models? So finding the right needle can be like finding a needle in a haystack. And so what typically gets done, right, is you choose a single model. You say, oh, that's the model. This is the model, and you draw inference from that model. But this can be really difficult to determine when the model space is large. And so you, what you can do though is you can look at models in the model space and assign them weights that are driven by the data. So you can rank the models, or then you can model average the models. So if each model gets a different weight, those weights sum to 100%, then you can average across those models to generate a prediction. And you can reduce the model space by reducing the number of models, either by eliminating variables based on theory, did that quite a bit. Combine variables, so you see this in principal component analysis a lot. This is not something that I do very often. I don't really like doing it because it sort of combines all these variables in a way that's very sort of difficult to understand and control for. You can cap the model size, and you can remove models from consideration based on the current set of explored models. And so then we can, sorry about that. There you go. So we can search the model space slowly by trial and error. We can do it a little faster using Metropolis Hastings. We can do it in parallel, or we can search for one model, like a lasso type approach, L1 regularization. Never found that being very good for prediction, so that's not my preferred choice. But that's in a limited sample. Okay. So there's different model selection criterion that you can use, and Bayesian information criterion is the easiest, is the one I could typically use. There's a K-key. Bayesian is more parsimonious. It chooses models with fewer explanatory variables, fewer characteristics of the students. K-key will choose more. Chi-key will choose more. And the Bayesian information criterion can be used as an approximation to the Bayes factor. All right, so techniques and relationships. So that whole model was just about the set of X's as and the Y. But what we really also need is the relationship between our X and our Y, right? So what does that relationship look like? Now, I will say that one of the things that we got to consider, and everybody probably, if you opened up your toolbox of data science skills, right? The hammer, one of the hammers in there, you have the OLS hammer. You also have the logit hammer, right? Or logistic regression type of hammer. Now, those are sort of parametric models that we can use, but they suffer from limited expressiveness, right? They're not able to capture maybe some of the important nuances or important nonlinearities that might be present. And let me give you a hypothetical example of where a nonlinearity might be present. If we look at a student who has less than a 5,000 EFC, that's expected family contribution, and that is determined by FAFSA. If we look at a student that has less than a 5,000, then it used to be that they would qualify for all sorts of grants, money that they did not have to pay back, right? So the retention probability might be higher than if we go to 5,001. Now all of a sudden at 5,001, You don't qualify for these grants. And so what do you see? You see a drop, right? You'd see a drop. And then as your expected family contribution grows up, your family's wealthier. So now as that grows up, then your retention probability starts to increase again. So it's flat, goes down, goes up. That would be like a nonlinearity that you could parametrically specify if you know about it a priori, but a lot of times we're not going to know about these things given the vast number of possible models and different interactions there. So what we can turn to are machine learning techniques. Now, these can overfit the data. What that means is that there's noise in this data, that we're not going to get everything exactly right. And so machine learning techniques can fit the noise in the data, which will undermine their predictive power on out-of-sample observations. Okay? But they have the capacity to recognize and to model unknown nonlinearities present in the data. Okay, and so what did I do? So I took a logit, and then I took multiple machine learning methods, and I estimated all of those. And then I looked at how they performed out of samples. So for example, if we took data from 2014 through 2015, trained on that, and then we predicted on 2016 data, and we have the realized values for 2016, then we would look at how well did I predict. And so there's an absolute prediction. What kind of prediction error should I make? And then there's predictions on different parts of the distribution, right? So if I said that these students in this bucket were at 60 to 70%, well, hopefully I see about 6 out of 10 of those students being retained, 6.5 out of 10 students being retained there. So I bin my data, and then I looked at different parts of the distribution. And then I try to establish the robustness of these techniques based on out-of-sample results. And then what did I do? I took each one of these techniques and I combined them together in an ensemble average. So you might think of, you got 10 stock pickers, for example, and they're all picking stocks for you. And as those stock pickers get more and more right, you're going to increase the weight on those stock pickers and decrease the weight on the other stock pickers. Same thing here. As these techniques got more and more right out of sample, then I would increase the weights on those and decrease the weights on others. Any questions? Yes.
So that's about the technique. But that technique is also being applied for different models, different sets of variables.
That's right.
So were you looking at how right the techniques were, but also across this multiple model space?
So when I model average, then I can get a composite prediction there, and then I can look at how that composite prediction from that model average for that specific technique, fits into it. All right, so one of the things I want to highlight, so it might seem like a lot of information, but it's the exact same pieces of information, just applied to models and techniques, right? So models identify a set of possible variables, call them candidate variables. Techniques identify a set of relevant techniques. Notice that on those techniques, you need to be aware of their limitations. There's quite a few, depending on the techniques that you choose. Determine model weights based on a performance criterion, BIC, AIC. For the techniques, determine technique weights based on some performance criterion. Increase weights of better models, increase weights of better techniques, combine different models using weights to get a model average. So Bayesian model averaging, you can look that up, it's all over the place. And then combine different techniques using weights to get an ensemble average. Okay, so now what are we trying to do here? With doing all of this work ahead of time, we're trying to get the most robust estimate of the relationship between scholarship dollars and our retention probability. Because we want to know with some sort of certainty that as we turn that scholarship knob, how well are we going to trace out the retention probability and the expected net revenue curve. Now, I want to take a step back and just put this in a broader context. Some of you are higher ed, some of you are not. But I think there's a more general principle at play here, and that's why I put this in yellow. It might be a point for discussion. Is that what people need to do if you're data scientists is you need to identify the key objectives for your business, and this requires domain-specific expertise. So each one of you are in an industry and have domain-specific expertise. You need to capture that. And then think about sort of the general context. And on that objective, break it up into your stochastic or random components and the non-stochastic components. For us, this was retention probability. For the non-stochastic was the net revenue. And then for the stochastic components, you need to identify the data sources, which variables or models are important drivers of key outcomes, identify which elements are control knobs for you, what things are actually under your control, and make sure that you have some good reasoning for that causal arrow, that as you turn that knob, you would see a change in outcome. And then be thoughtful about and establish robustness of your techniques and models that you choose, and then optimize over the objective to generate data-driven value-added recommendations. And then you may say, well, why do we want to do this? We can talk about possible industries here, but why do we want to do this? Data scientists obviously need to generate contributions that add more value to their companies than their salary. And so I'm an academic, so I sit in my little sandbox, right, and do academic research, and it's a lot of fun. I have great times doing this. But I also know that when I step foot into a company, that this is the underlying motive, that I need to add more value to my company than my salary is covering. And one thing I'm worried about is I think that routine tasks of prediction and explanation, things that we see every day, are going to become more and more automated, that we can just feed in a bunch of X's and Y's, and all of a sudden it'll spit out some results for us. Right? And what is this going to do? It's going to put downward pressure on our salaries as data scientists. Now, where we can make a difference and where we can differentiate ourselves from a statistical software package is the embedding of these business objectives into our analytics process. This is going to be extremely difficult to automate because every business, every industry, every firm is going to have a different objective and a different way of framing that objective. And so to the extent that you can do this, then you are adding huge value. You can have the potential to add huge value to your company. And once again, and if you can do that, then that should put upward pressure on your wages as well. And the only thing is, once again, you need to be careful about the robustness of the chosen model technique combination in generating these recommendations. So when I first started doing this, it was a logit, and it didn't work well when I was doing practice. And then when I started my work with OU, then I changed that up to include a broader set of techniques and averaged over them. So, any questions? Thanks. Yep. Right, yeah.
So, say if you go for a longer data set, say 2011 to 2015, and would there be changes in the patterns, like from say 2011 and 2015 data set, and how would you account?
Okay, so yeah, I would go back, typically I would go back 2 years or so, and I think that would capture a lot. One of the problems there is that I had so I was using algorithms scaled at O n cubed, right? And on the training data set, you would have, I think you would have about 4,000 or so, and that's all right. But I wanted to speed up the process. So, and I didn't find that adding additional years beyond that really added much value.
One more thing is, could this problem be framed as a multi-objective optimization kind of thing?
Yeah. So it could, right? So you could think of. Okay, so there's some issues, right? So when you're talking about multi-objective programming, are you talking about that you're going to impose certain restrictions on smoothness?
But yeah, the probability side, there's uncertainty, so you can't exactly.
Okay, so there's a couple different ways of framing this, right? So depending on the techniques that you use, if you just use the logit, yeah, you would be able to use that because really you have typically a monotonic relationship there. That as the scholarship dollars go up, you would see retention probability goes up, and so you could do that across all students. I think you should be able to do that there, because your expected net revenue has this nice curve. Now, when you get to the machine learning world, then you introduce some additional non-linearities. That there can be some bumps that might forestall it. And so then you have to generate workarounds in that respect. Does that sort of make sense? Because typically on these optimization type of problems, you have to have some sort of assumptions on like the smoothness, right? Yeah. You don't want to get stuck in a local optima.
How did you prove to the university that this project was as valuable as the cost of all of the man hours and different departments that would be required to come together to for this?
Okay, so that is sort of a loaded question. I will say that we can talk. I'll give a brief answer now, and then I will talk to you right after. After this. So, but what I will say is that they have a full retention team there, and they do an excellent job, and they have it's a multi-pronged approach on retention. And I was a part of that approach. My part involved a little bit of upfront cost for them to set up an environment. So one of the things that I tried to do, I didn't charge a whole bunch for my services. And this is one of the things in higher ed, I feel like consultants charge a lot. I don't charge a lot for my services because I wanted to leave money on the table for scholarship dollars for students. So I didn't charge very much. Where the costs were incurred is they set up an environment at the university, and I operated in that environment. That gave them full control over their data, but contractually we agreed that I would have the rights to all the code that I would write. Okay, and so they incurred costs from that environment. Those are internal costs. I'm not sure how the university licensing system really works. The other cost on their part was they had to port data from the Banner database into my SQL Server database. And so they set that up. But everything, once they got that into my database, I wrote all the views to compile the information like I needed. I wrote all the software or the processing, the code to process that information, to generate the results, to put those results back in the table and generate a report. So that was my thing. So we try to keep that cost internal to the university. And so it was done, it wasn't a particularly expensive project, I guess. I wouldn't think. I don't know. You could ask them. They would have
I was just curious how you were able to prove to them that the cost would be worth the gain.
The cost would be worth the gain. So the cost is low. So now the question is, here's the gain. And so on the gains side, first year I worked with them, they went from an 86.1% to a 90.4% retention rate. Now, I'm not going to attribute that all to me because like I said, they've done a lot of work in a lot of different areas to affect their retention rate. But there was some indication that some part of that was attributable to me, and I can talk about that offline. Yeah. Other questions? Yeah.
You have some kind of graph to show what variables affected the retention the most, the retention probability?
Yeah, I do have a presentation that I gave to them that showed which of those variables for OU affected it the most. Yeah.
No, on top of your mind, what are the top 3 variables that affected the retention the most?
Yeah, some of that would be like the secret sauce, though. So I don't know if I can share, but yeah, I know at least a couple that would be very important there. Yeah.
So one more question is that how did you handle what variables to include? For example, the data might say that the ethnicity or the sex of the student is correlated with the retention, but you can't use those, right? Because you'll be biased by the data. How did you?
Right.
That's a very thin line
to. Great point. There are some variables that you want to exclude, not because they don't have predictive power. They may have predictive power, but they may lead to other issues, right? Ethnicity being one of them, or race. So those sort of variables I steer clear of, right? I do not want to be. I want to sort of be blind to that in the model, to be blind, even if it causes a decrease in predictive performance.
One more question is that I'm seeing a lot of parallel between this project and a typical portfolio optimization problem, wherein every student has a risk associated uh, with them, and like the overall objective is to increase the retention, right? So how did you model the risk associated with every student? Like, was the retention probability kicking out a single value, or was it kicking out a probability, like a probability distribution?
Okay, so what did I give to them?
Like, how did you model the risk associated with the
How do I model the what?
the risk?
The risk associated, yeah, okay. That's a good question. That's not, so, you know, in theory, right, if we go back to our optimization, we had certain conditions met. We could do like a Markowitz portfolio optimization where we're trying to allocate these things and take account to the risk. I didn't actually, in that case, I didn't look at the sort of the spread of outcomes for the individual student. So what we did look at is, what I did look at is what were the gains in retention probability for an individual student, but I didn't look at sort of the prediction interval for that student. That's a good question.
Whatever. Okay, you were talking about the secret sauce. Now, without wanting to know the ingredients, how much of it would work as well in a different college in another corner of the nation, or you would have to tweak it, and how much?
Oh, see, these are great questions, right? This is great. Okay, so I think, and I haven't just explored this extensively, but I think it also depends on the drivers of retention, right? So there might be universities where the driver of attrition at a university is academic. Like, it's really hard, people fail out. There's might be others that the driver of attrition is financial, right? So this is going to work really well for financial, but this might not work as well if you go to a university where the main driver of attrition is going to be the academic part of the piece, right? Where maybe the professors are asking them to perform at a very high level and they're not prepared to do that. And so that's where it might not work very well. But in those other set of universities where it's a lot of the students are leaving for financial reasons, this should work. And what would happen, right, is that the model weights would adjust on the characteristics to accommodate the particularities of that university. Yeah.
Most university, it's a blend, right? There's not going to be one university won't just be purely financially driven,
right,
but the students, so it'll be a blend. And you mentioned that they're looking at all these different aspects. So I'm assuming in the academic zone, someone's making models to calculate that. So can you actually do a multivariate analysis to put many pieces together?
Yeah, and so that is basically what I did, right? So if you think about it, in that retention probability, you're going to have characteristics like how far, so some general ones, how far away are they from home? What's their financial situation? What's their high school GPA, their ACT? What is their fall semester GPA? And so you've got this collection of variables. And then you also have from down here, right, the social integration piece. So you take the social network, roll it up into a centrality measure, plug it in. And so then you're sort of building this model higher up, and then you can, from that, you can use it in this, right? So that would be a multivariate analysis.
But that just made, next to the speaker with the microphones, the right thing. So that just made me think of some of these like personalized medicine challenges where you sort of think of your population like a homogeneous population. And so you apply a single model to it, or even if it's an ensemble model, like it's not a single model. But I was just thinking like the distance that somebody is from home, there might be a group of students for which that increases attrition, and there might be another group of students for which that decreases attrition. Like the further they are away from home, the idea that they might have to go back from home makes them want to stay in school, and another set of students where they miss home and they want. And so I just wonder, do you have any thoughts about like where this could be taken by trying to end up with like a more nuanced clustering of different types of students and then applying the same sort of analysis at a more granular level to subgroups of the population? Or do you feel like that's kind of taken in a certain way that's taken into account by the ensemble modeling, but yeah.
Sort of, right? So
Yeah.
I think there's a couple answers there. One, I said distance, but actually I use lat and long, right? So there's a difference there. Distance, you put like at OCU, you would put a stake in the ground and then you would draw a circle around. But lat and long actually allows us to figure out, well, sort of it's not just the distance, but it's the direction that matters as well. So that's one part. So that's sort of backing up saying, well, our assumption of distance is too strong. Let's break that up into lat and long. And then your other part is basically introducing non-stationary behavior into the model. So we need to choose techniques that would at least allow us to identify some of these non-stationary behavior, that there would be breaks. But those breaks have to be along some sort of identifiable means, right? Some sort of identifiable traits. And so if you're in your example, if we're not able to find a characteristic that allows us to break the students, then it would just be attributed to noise. But if you're saying that people from Texas love Oklahoma, they want to go back, people from Arkansas want to go back, then using lat long would do that.
But I guess I realize that's actually part of the power of what you did with the multiple techniques, because some of those techniques could have allowed for these sort of, like you said, nonlinearities that could be that based on one variable, there's sort of a different equation than other branch of the tree.
Different prevailing relationship in that region versus another.
Right,
region.
right.
Yeah, question?
Do you have any plans to take this elsewhere? I'd imagine there's other colleges in Oklahoma even that could benefit from it.
Yeah, well, I want to give OU credit. They are very innovative. They are at the cutting edge of what is being done in analytics in the higher ed space, and they are open to new technologies and trying new things. And so they have Banner, makes it real easy. They have a SQL Server environment, makes it real easy. I can virtual into their machine, so data security is not an issue because it resides on their servers.
Yeah.
And so they have all these things that allow for it to be sort of easy. And so other universities, as they're getting there, I think, yeah, there might be more opportunities that open up in that space.
I've been amazed to see how much of the project was all your direct work. I think I assumed that it would have required a lot more staff to pull it all together.
Well, the provost, the vice provost, Glenn Krutz, Glenn Hansen, those guys sort of were the ones that sort of opened all the doors to get the people on board. We had Chris Kennedy was a guy that got the Banner data out of the database and into my virtual environment. Bruce Alcott was the guy that set up my virtual environment. So there were people there. I'm not taking away from what they've done at all. They did a great job. But once they got all that there, then I just sort of hit the ground running.
I'm very new to data science, so I've been interested to hear how much involvement across start to finish it requires.
Yeah. Well, if you know SQL, then that's a necessary, maybe not sufficient, but necessary condition to do data science, right?
So we had a lot of questions about sort of different data science aspects, but one part of your talk I really liked was this focus on this idea of like business process, or like business objective programming, and I liked the point you made about the path of automation and certain things being easier to automate and certain things being harder to automate. I agree with you that I think this task of trying to sort of translate a business objective into something that that you can do data science on, that's hard. It's hard to automate. So I'm curious, if there's certain skill, like you do a lot of this because you do a bunch of consulting and you have this focus on this sort of business objective perspective, what skills does that require that a data, like I'm, you know, to the extent that there's data scientists here and they're sort of stacking up their skills, like they know SQL, they know R, they know this, but then it's a different set of skills to be good at this other thing you're talking about, right? Like listening. And do you have any thoughts about what you think those skills are, or how you would encourage people to get good at that aspect?
So I think that's where my econ comes into play, right? I'm always thinking about the business side and the business models. And so econ is all about writing out these models, these mathematical models, and you're saying, when, you know, some people are saying, when am I ever going to use this, right? And then apparently comes to play when you're doing data science that you say, I can combine my data science skills, I can combine my SQL skills. I was a database programmer for 2.5 years, so I realized I can combine these skills with these skills and my econ skills to sort of generate an outcome that's different than what other people are providing in the marketplace. And so I would say just go back to your business and think about those fundamental problems, right? And if you can, and here, one thing that I will say, it like in this particular situation, right? Most academics will say, we want you to focus on retention, and that is the case. We want you to, but you got to see that there's a trade-off there, and some people don't see that trade-off, and so trying to understand what is the trade-offs and what you're trying to ask me to achieve, right? Oh, sorry about that. And but I can see this playing out in many different cases, right? If you're looking at human resources, you might think, I'm going to make a wage offer to an individual. What's the probability that they'd accept at a given wage? And so you can think of what's the revenue stream that they would generate. So you might be willing to offer a higher wage to an MIT grad than to somebody else. And so anyway, so you can think about retail. You can think about coupons and how you might look at probabilities of purchasing and how those are changed with the introduction of coupons, online coupons versus mail coupons. You can look at sales. There's a whole host of industries, but you have to start, I think you talk to those domain experts, you ask them what they know, then you try to figure out what those trade-offs are, then put those into a data science framework. You don't start with the data science and then try to build up from there.
I love that was your point just now was giving examples in other industries where it can be used, because one of the things that Data Plus Creativity really got started of innovation, but specifically this innovation in the form of exaptation, where you're taking a technique from one industry and another domain and having these really innovative. So I wanted to actually ask the audience if any of you were listening to the presentation and thought of ways that it applied to your field, if you thought anything like that, and if you didn't mind sharing.
Hey guys. So I work at Osberg. We are a market intelligence, oil and gas kind of tech startup. Kind of similar to you guys, but different field. Same, but different. I get a lot of ideas, a lot of business analyst ideas. And one of the problems that we face, much like students, is not all oil and gas companies are the same. You have Devon, which has a giant tower in the middle of Oklahoma City that everybody uses as a point of reference. Or if you don't, I do. And then you also have small companies, companies that are only 4 people that operate in an office in a part of a bigger strip mall office space, something like that. Yeah, yeah, I think they've got some empty floors in there. No offense to anybody that works at Devon, sorry. But with that, it's not sales team. They do their own thing, but not everybody can be treated the same. You have to have some level of price discrimination on retention, and then whether or not we keep them and they churn. Is it worth giving them that discount? And brings up a good question that we need to be gathering data around our clients as you gather data around students.
Right. Yeah. Fantastic.
So I work in the game development industry here in Oklahoma, and one of the things that we look at with in terms of like data collection is like we do like telemetry data. So we can actually have our players be connected to a server, and we can actually have them play through levels, and we can actually collect all that data for them.
Did you work at Goldfire?
No. I started my own little company thing, so I'm a little guy in a strip mall type thing. So, or more of an apartment. So anyway, so we can do things like, gather that data, and we use that to try and see like, okay, here's where all our players are dying all the time. We're making this thing like way too hard. And so like you have that retention rate of like, if you kill your player too many times, they're just going to quit and uninstall, so there's that business, we like at the heart of like a game company, you want to make things fun, but at the end of the day, you want to get money in your bank account. So you want to keep them playing. So, but yeah, like when you were talking about like the retention rate of stuff, I was like, oh yeah, I've been studying stuff like that, like making sure that, people keep coming back. So yeah, so anyway.
Do you have like in-game prizes and stuff like that as well? In-game purchases and prizes?
Yeah, so we tend to stay away from like the microtransaction type of thing, but we try and see if one thing I've been researching is with that telemetry data, like the in-game prizes that you can get, like the loot type system, like is that something like from the data, is that something that like gets them into like the next level, they keep playing, or do they get something and then it's like, did they do this like really hard thing and then is it something where they just kind of cash out and they're like, okay, I'm kind of done,
Right.
So that's the thing. It's kind of interesting because I've also been seeing this in like, as I've been researching it, I've been seeing it like in games that I actually play myself, where I realize like, hey, I'm done with these like quests for the day or something like that, and then I just stop playing and I don't pick up the game again until tomorrow. So I'm wondering like how these kind of things can apply. Like, how do you get someone to not just stop when they are like done with their little tasks or whatever? Like, how do you get them to just keep playing, and then even like if you do have like microtransactions or something like that, like pump more money into the game?
Is there a social component to it as well?
On ours, no, not right now. But it is like, it's one of those things where like you do this research and you start to see all these things and your ideas start going, it's like, oh, could we add a social component? It's like, I'm only like one guy, so probably not. So, but yeah. So,
Cool.
yeah.
Good luck.
Thanks.
So I thought that was a really cool kind of acceptation, because it was a case where like money is not the same as money, and like retention isn't exactly the same as retention. It's like in this case, the scholarship you're giving is actually just like, I don't know, making the game a little easier, or trying to like help them out. You're not giving them like a money scholarship. You're sort of giving them life scholarship or something. And then and so I'm just making me think like, so what are the other things like that where the analogy is to something different, like I was
different control law, right?
yeah. But also like, I was thinking about like exercise or eating or things like this. Like what are certain things where the sort of quote scholarship that you might give is not financial, but that the same logic still applies, that there's attrition and not. Josh?
Yeah, I think I've got one. I used to work with brain machine interfaces, and we worked with monkeys for that, because it's really kind of dangerous to do that with humans. This is we're working on kind of like next gen prosthetics, arms that were controlled by the brain signals, and so for us it was apple juice. Basically, like we have these.
Not bananas?
No, so we have these monkeys, right, and they're like sitting in chairs, and the goal is like we're trying to learn how to get them to control this robot arm to like pick something up off the wall, and like eventually, I mean, just like trying to read some like new technical material or something, like you kind of get tired. You're like, I'm done with this for now, right? Like they get kind of frustrated. They're sitting here like this is maybe as comfortable as like where I just came from my other room and everything. But they pull the thing off the wall. If that's not motivation enough, here's some apple juice, So they hold on to like a little tube and they get a juice squirt every time. So seems like the same kind of thing.
Yeah.
I was going to go back to your point, and I'll throw it to you in a second. But that's like the beauty of economics, and like where economics and data science kind of blend together. It's that like economics, the study of incentives and rewards and punishments, and I mean it's every day. It's life. It's deciding to turn right on a red, given that cars are coming from the left. It's, do I drive to go get food, or do I have it delivered? It's everywhere. It's crazy. But yeah.
I think it was kind of said before with human resources, but so actually one of the jobs I'm currently working for, guys developing an HRIS system, and I'll be testing the data output to make sure it works right. And just about everything his company develops is HRIS with the intent of incentivizing existing employees.
Yeah.
Rather than just when you're first hiring them, deciding bonuses instead of scholarships and all the different things that you can incentivize an employee with.
Sure.
Including apple juice, I'm sure.
I was just thinking about, I was realizing like in the analogy, it's not as simple as just sort of like a control knob that diminishes retention or something like that. Because what was interesting about this is that you had these two outputs that were sort of at odds with each other, like the revenue and the retention, right? And that was what was interesting about your system, is it was trying to balance both. And so I was just thinking about certain medical treatments where, like chemotherapy is pretty intense. And if you give enough chemotherapy, then you're probably going to kill all the cancer, but you're probably going to kill all the non-cancer too, right? And so, so that's actually a case where like you want, like if the cancer cell are the students, like you want them to drop out, like, and I wonder if there's a similar opportunity in that you're turning one control knob, which is sort of dosage. And what you want to do is you want to sort of understand that peak in the expected value, where it's like after a certain amount, more dosage, it's going to have more harm on the, on the body than it's going to have. And I just wonder if there's an application in what you've been doing to sort of fine tune dosage of certain treatments that have this both positive and negative effect, in the same way that you're kind of fine tuning the dosage of the money that you give to each.
Right. That's a great point. Yeah. Do you have a data set you can look at?
Well, yeah, we have to, if anybody here is from the, oncology or something and wants to, that's a new consulting project. Give me 2% when you get the contract.
I'll probably try to do that for free, actually.
Like I'm having a lot more ideas now that I think about that, like trying to stop something instead of like keeping something going, like stopping malaria is like that, and mosquitoes. Same thing. It's like use mosquito nets to use this. How much? I have so much money to sources to these countries.
And I will say, even in this higher ed space, right, we have multiple control knobs. We don't just have financial. If it's an academic issue, maybe we could assign tutors. If it's a social issue, right, they're not connected at all, then let's try to figure out how we might incentivize them to join some groups and participate in some groups so they don't feel as lonely being so far away from home, right? So we have multiple control knobs. We only just not exploited, but used one of those.
Eric, what's the climate change? Climate change must have a problem. I mean, it clearly has a problem with incentives, right? Like, is there a case where this sort of like finding the intervention where you incentivize the farmer to use less water but not kill all his crops or something?
Or in incentivizing I can say this because my father-in-law's in the oil and natural gas industry, but right, with the wind and solar, like you incentivize, you provide money, which is a net loss, but then or you put a tax on oil, on carbon, and then that's a big negative for the companies, but then eventually the other companies will build up solar and wind, and so that's a trade-off. That's a big fight right now. In other words, yeah. I had another thought. I'll come back to me. And I did like that last part about combining the academic, because I really like your plot that showed the people on the edge are the ones that you need to work at, not the ones in the center. And so you could see like financial, you find those on the edge. Academic, you find those on the edge. Like each of those components, you only have to find the people that are on the edge, not the ones in the center. I like that.
You're right. If you discount the ones that are in the center, you're over discounting and you're dropping your sort of your bottom line. And so really what you want to do, your objective is to enhance retention in the most sort of financially responsible manner possible. And this is the way to do that.
I did want to kind of start bringing things to a wrap up. Can we all give Dr. Dearman a big round of applause, please? There's still some food, so you don't feel like you have to rush out. Please keep talking and there's obviously lots of great questions out there and good discussion to be had. And have more food, have more conversation, and next month on April 26th, I think is the Thursday we're gonna have our next meetup. We'll be having a nerdy movie night. It's been a long time since we've done one of those, and I'm excited for it because we're gonna show a film called Hackathon that we filmed in our company at one of our exercises. And it's this really great story about some of the things we've been talking about tonight, subject matter experts plus data scientists, and finding out how to overcome communication obstacles and really work together to produce some amazing tools. So I hope you'll join us for that. We're also going to be creating a cognitive city for our Data Plus creativity community. And it's going to be an exciting opportunity to not just talk about innovation, but collaborate together and come up with projects that we want to do as a community that's interested in having impact and something to add.
Yeah, one of the things that Jill and I have, talked about as we've sort of been reflecting on how this community has taken form and some of the ideas that come out of it, is that it just seems like every time we have one of these meetings, there are really neat ideas that come out of it. Like maybe there's a new idea for video game optimization or something, or now Jacob's going to do work for free using his techniques for chemotherapy or something like that. And but we'd really love, to the extent that some of these things are maybe not just sort of an idle idea that gets lost, we'd love to create a sort of nucleation site where ideas that come up like that can get captured. And if other people in the community are looking to take part, like there might be somebody else that would like to work with them on that, and or would like to work with Jack on, this new idea around making the game just playable enough that people never quite give up, right? And so this is part of what we're excited to do, is try and create this network of this group and other people that take part. So as ideas bubble up, people could do their own hackathons around them, or other ideas could come out of it.